In the previous video, we looked at the dot product. So in this video, we're going to take a look at two of the ways that we can use the dot product. So let's say for some reason that we have an angle that exists between two non-zero vectors in standard position, such that the angle is between 0 and pi. Well, we can find that angle by using this formula. So the cos of theta is going to be equal to u dot v divided by magnitude u magnitude v. Sorry, I got messed up. So all we have to do is just find u dot v, u, magnitude v, and then multiply and divide, and then just go through and find um, the inverse cosine of this. So let's start by taking these two vectors and finding the angle that exists between them. All right, and just to get an idea of what we're looking at here, all right, just to graph this, we have 3, -2, which is going to be this vector in standard position, okay, about that vector, okay? And then we have -1, 5, right, which would be this vector. And this is the angle theta that we're looking for, all right? So theta is going to be what, like 130, 140, something like that, all right? Just by guessing and looking at it, it's probably closer to 180 than it is for something else. So let's start by finding magnitude of u, okay? And that's just going to be the square root of 3 square plus -2 square, which is square root of 13. Okay, I think we can pretty easily compute that. Next thing I'm going to do is I'm going to find the magnitude of v, and the magnitude of v is going to be equal to the square root of -1 square plus 5 square, which is the square root of 26. Okay. Finally, if I wanted to find the dot product, u dot v, right, that's going to be 3 times -1. So remember, we multiply the x components plus -2 times 5, right? And that's going to work out to be a -13, right? So now if we throw this all together, right, we're going to get that the cosine of theta is going to be equal to -13 divided by the square root of 13 times the square root of 26, right? Now, this one's actually really cool because we can actually get a full angle for this one, all right? But let's go ahead and we can just use our calculator, okay? And this is actually going to work out to be something really nice for us, okay? So theta is going to be equal to the inverse cosine of -13 divided by the square root of 13 times the square root of 26. And let's just go in our scientific calculator and figure that out. Okay, so we're going to find an inverse cos, and we're going to have -13 divided by, now be careful when you're dividing this, we have the square root of 13, and then we have the square root of 26, all right? And notice that this gives us exactly 135 degrees, all right? If you went through a little bit of pain, what you would go through see is that this expression simplifies into 1 over this -1 over the square root of 2, and you can rationalize that to be -√2 over 2. Okay, so this is just 135 degrees, which is, again, really nice because we can just use our calculators to figure that out. Okay, but for those of you that want to figure out how to do it without the calculator, you'd have to simplify the expression to -√2 over 2 and then find the inverse cosine of that. Now, this is one that doesn't have a nice exact value, so we are going to have to round this one. So we have -1, 2, and 3, 6. All right, so magnitude of u, that's going to be equal to the square root of -1 square plus 2 square, which is √5. The magnitude of v is going to be the square root of 3 square plus 6 square, right? And that's going to be 9 plus 36, which is going to be 45. Right? Um, so 3 square or 9 plus 36, 45. And then u dot v, that's going to be equal to -1 times 3 plus 2 times 6. Okay. And that's going to be -3 plus 12, which is 9. Okay. So this is going to be, if we throw this all together, cos of theta is going to be equal to u dot v, which is 9, divided by √5 times √45, right? And then from here, what we can do is we can just find the angle by finding the inverse cos. Okay, so that's inverse cos of 9 over √5 times √45, right? And this one doesn't work out perfectly, or I don't think it does. But let's see what happens as we go through and try to evaluate this. So we know the numerator is going to be 9, and then we have √5 and √45. All right, and we get 53.1 degrees, okay? I believe it asks us to round to the nearest tenth, okay? So that becomes 53.1 degrees, okay? So pretty easy for us to be able to find the angle between two vectors, okay? We just use this formula and we're good to go. Now, orthogonal vectors, this is even easier than what we just looked at. Two vectors are orthogonal if what happens is when they intersect, they form a 90-degree angle, okay? Now, one way to determine if two vectors are orthogonal is just by taking the dot product, and if the dot product is 0, okay? For those of you guys that care why that is, remember our formula that we just had, cos of theta equals u dot v divided by magnitude u, magnitude v. Well, what if u dot v was 0? Well, that means we would end up with cos of theta is equal to 0, and the inverse cos of 0 is 90 degrees, okay? So that's why if the dot product is 0, that two vectors are orthogonal, okay? So if you take the dot product of two vectors and it ends up being 0, they are indeed orthogonal, all right? So, and later in mathematics, orthogonal means a lot to us, okay? For right now, we're just trying to determine if they are orthogonal or not. So here's two vectors, okay? So we just go through. We find the dot product. So we have 4, -3, plus 1 times 12, -12 plus 12 equals 0. Okay. And you would say, yes, since u dot v equals 0, they are orthogonal. Okay. So really easy to determine if two vectors are orthogonal. We have this one, this equal sign shouldn't be there. So we would have u dot v would be equal to 3 times 3 plus -3 times 4. That would be 9 minus 12, which is -3, which is clearly not equal to 0. So we would say, since u dot v is not equal to 0, u and v are not orthogonal. Okay, now we can still find the angle between them, okay, but that angle would not be 90 degrees. Okay. All right. So really easy for us to be able to determine if two vectors are orthogonal. Fairly easy for us to be able to find the angle that exists between two vectors. Okay. One more video. We're going to take a look at what it means for a vector projection. So in other words, when we project a vector onto another vector, what does that look like?